Hello, computer philosophers out there. If there's one thing I have been looking for all my life, it is a method to bring order into knowledge. Like the alphabet. Apple is next to banana, is next to chipmunk. It is A, B, C. But this is about the words only, not about their meaning. What I really wanted is a system where a car is adjacent not only to the drive, but also to a bus, a bike, a garage, petrol, tires, and vacation. And if this requires a multi-dimensional mind map, so be it. And exactly this is what vector databases are about. With vector databases, every term will be associated with a vector that points into a multi-dimensional room of meanings. This finally allows you to compare apples and oranges. The vector of apple will be closer to the vector of orange than, say, the vector of daylight. So an apple is more similar to an orange than to daylight. And wise men have shown that if you take the vector of Hitler, subtract Germany and add Italy, you end up pretty close to Mussolini. Now, this is not only a fascinating philosophical concept, but it is also commercially useful. Imagine a web shop where someone searches for chocolate, but the shop does not have any. So what would you rather offer as a substitute for chocolate? Would it be sweets or a bicycle? With a vector database, your AI finds out. So let's get our feet wet with the first Hello World-like program where we use vector technology. Okay, so here we have a script, vector.py, a Python script, and you can download it from my GitHub repository. I put a link into the video description, and then I say Python vector.py and type enter, and now it starts loading the word embeddings, and you can see down here that it is running with 100% of one CPU core, doing nothing else but loading the embeddings. This gives us the time to discuss the script. It starts with importing gensim. So you have to do a pip install gemsim before you run the script. Then it asks you for two words. Input word 1 means that you will be shown word 1 as a prompt, and you have to type the word, and this will be stored in word 1. Based on this, a vector will be calculated or will be looked up. Based on this, the similarity will be calculated, all using a model that is accessible from Google. And in the end, it will output the similarity between the two words. So let's see how this will play out. The stuff is still loading, and let's wait for it. Word 1, I take apple. Word 2, I also take apple. Should not be much difference. And indeed, it says the similarity is 1.0, so cannot be more similar. And as I said, as I promised, I will compare apples and oranges. So the similarity is almost 0.4. In German, we say comparing Äpfel and Birnen, so apples and pears. So let's compare this as well. And there the similarity is even higher than between apple and banana, which is a good sign because a pear rather looks like an apple than a banana looks like an apple. It just comes to my mind I could also compare one apple with multiple oranges. And there it is now higher. Funny fact, okay. And now we compare apple with daylight. And see that the similarity is very, very small. Compare apple with Germany. And also here, the similarity is very small. So if you have a web shop and someone searches for an apple, don't offer them to buy Germany instead. Offer them bananas, pears, whatever, but not Germany or no persons, okay? So this is what we have learned from lesson 1 about vector databases. Thank you.